Greetings, mathophiles. This video will give a short discussion of some issues having to do with learning calculus. It's aimed at students who are considering taking calculus, who are just beginning to take calculus, or who simply are looking for some advice about ways to think about learning calculus. You may also be interested in a couple of forthcoming videos, one on 4 really useful books for math students and one specifically on retrieval practice. When those are up, I'll put links to them in the description for this video. Calculus is about 2 problems. The first is the tangent line problem, how to find a slope of a line tangent to a curve when it's not an arc of a circle. The second is the area problem, how to find areas of regions with boundaries that are not line segments or arcs of circles or other familiar geometric curves. The former problem is addressed by means of an object called a derivative, and the latter by an object called a definite integral. These 2 problems are connected in 2 foundational ways. First, the derivative and the integral are both instances of objects called limits. And second, the fundamental theorem of calculus reveals a type of inverse relationship between the 2 problems. In some ways, calculus is like any other math course you've taken. There are formulas, theorems, problem types, typical applications. But in some ways, calculus is different. First, you need reliable recall of quite a bit of prerequisite knowledge. Things like factoring patterns, trig formulas, techniques for graphing functions. You can't just sort of learn it and get tested on it and forget it, because it needs to be accessible to you as you go forward and integrate it into the new material that you're learning. Second, there are a lot more formulas, and it's more necessary to know them well. We'll say a little bit more about that in a moment. And finally, while it's certainly possible to categorize various facets of the material forms a coherent whole to a greater extent than you've previously experienced. And the more you're able to assemble the pieces together and see the connections across them, the more successful you're going to be. When I think about calculus, and in fact, when I write comments about my own students, I tend to categorize the knowledge in 3 sort of broad categories. First is the mechanical or the procedural or the formula-based facet of the work. In terms of success in a class, this is the first among equals because you can't get right answers without possessing these basic skills. The second is what we might call the theory, the conceptual structure embedded in the key definitions in the theorems. What actually is a derivative? What actually is an integral? How are they connected to one another? Things of this kind. And finally, there are the applications, which are numerous and interesting and practical. Ideally, these elements should all work together. At first, it's not going to feel as though they are. But as you learn more, you're going to make more connections, and a fuller picture is going to emerge for you. So if you've just begun a course and it's the 3rd week in September, and it's not obvious to you why we're doing the things we're doing and why you're learning the things you're learning, sit tight for a little while because you'll begin to assemble a much more clear idea of where it's all going before too much longer. How do you succeed in calculus class? A lot of it is the same as it ever was in terms of being attentive, taking care of assignments, being engaged in class, all of these things. But some elements take on an added importance. First, you really need to stay caught up. Jump on any difficulties that you may have with concepts or procedures. Check out a YouTube video, check with your teacher, check with a classmate. Get things cleared up as they arise, and they will. Because if you do that, you'll be all right. When people get into trouble, it's when they let stuff snowball and snowball and snowball until the task of digging out seems insurmountable. Second, use retrieval practice to automate whatever can be automated. Calculus is complex. Some of it takes pretty high-level reasoning and problem-solving skills. And if you can make the mechanical part truly mechanical, truly automatic, that's going to be a great help to you. Use flashcards to help you memorize formulas. That would be a canonical example of retrieval practice in calculus. And we'll expand on retrieval practice in a future video. Meanwhile, you might want to track down a really helpful book called Make It Stick. I'll give the ISBN and the other information in the description for this video. Finally, be particularly rigorous in your self-assessment. It's easy to read through notes and say, yep, I know that, read through a portion of a textbook and say, yep, I know that, than it is to actually do the work solo without a net. But doing the work solo without a net, solving problems, writing explanations, that's what you're going to be asked to do on tests in your class, IB exams, AP exams, whatever the case may be. You want to avoid this thing that's called the illusion of mastery, where you study in ways that are ineffective but make you think you know it, rather than in ways that are effective, and ways in which you demonstrate that you do really actually know how to do the things that you've been asked to do. This book, Make It Stick, has some good information on this as well. I hope this brief discussion will be of help to those of you embarking on the study of calculus. It's a treat. It really is. It's a wonderful, wonderful discipline. But how you approach it has a lot to do with how successful you'll be with it. So good luck and happy mathing.